All right, hi there. This is video number 25. Chapter 11, Section 2. And this is all about arithmetic sequences. All right, you need a little bit of a definition here at the beginning and then a couple formulas, and then we're going to get to work. So, the beginning. An arithmetic sequence is a sequence of numbers in which each term is obtained from the preceding term by adding, and that's actually really important, the same amount each time wait a minute. All right, let me erase instead. Each time, and that amount is called the common difference. And is denoted by D. Okay, so that may not make a whole lot of sense yet, but it will at some point. Basically, we're saying we're adding the same amount from one term to the next. So, example, if I start with the number 4 and I add 3, add 3, add 3, add 3, add 3, you can tell that 3 is being added to every single term. That's an arithmetic sequence where you're adding, the difference is 3 between every single term. So this makes it an arithmetic sequence because every term has a 3 between it, and D would be equal to 3. Okay, so that's what you kind of need to know right now. All right, formulas. Okay, the general term or remember that's also called the nth term, with the first term of a sub 1 and the common difference of D is a sub n equals a sub 1 plus the quantity of n minus 1 times D. And you should probably highlight that or put it in a box or something on your page somewhere, because you're going to use that a lot. And you also need to remember that this is specifically for arithmetic sequences, right? Because you're also going to have something called geometric sequences, and you'll have another general term, a formula for a general term, and it's completely different from that one. So you need to know keep them separate from each other. All right, so next, we also have a formula. Let's get down the page a little bit. You have a formula for the sum of the first n terms. So obviously we're talking about a finite right? If we're talking about the first n terms, it has an end. The sum of the first n terms, and that formula is S sub n, capital S, is equal to n over 2 times the quantity a sub 1 plus a sub n. So you need to know a few things in order to be able to use those formulas. Again, I would highlight. All right, and that's the end of the actual, there's only those two formulas that you need to have. So now let's go on and talk about some actual examples. All right, here's one. Determine if 65, 60, 55, 50, ... is an arithmetic sequence Varsity actually uses the word progression, which I will use. If it is, identify the common difference, comma D. If not, answer D and E. So I took the entire set of directions straight out of Varsity here. All right, so when I do these, I like to start by just kind of writing these in order. 65, 60, 55, 50, and then just do this. What's the difference between them? Well, I go down 5, down 5, down 5, and because these are all the same, then yes, this is a arithmetic sequence or progression. Again, that's the word that Varsity is using. And D is equal to -5. Okay, so D can be negative. That's an okay thing that can actually happen. All right, next question. I'm going to actually go to a new page here. New page, throw some paper in. Okay, determine if 1/4, 3/2, 11/4, 4 is an arithmetic progression. I'm going to squeeze it in. All right, so this does not look good. However, if you actually take, so we're going to start with 4. 4 minus 11/4. And if you put that into a calculator, you're going to get 5/4. So this was taking, this is a sub 1, a sub 2, a sub 3, a sub 4. So this is a sub 4 minus a sub 3. Now I'm going to go 11/4, a sub 3, and subtract off 3/2, a sub 2. And guess what happens? You get 5/4. And then I'm going to take a sub 3 and subtract off a sub 1. Again, guess what happens? You get 5/4. So, while this does not look good, that certainly does not look like any kind of sequence or anything that you've ever seen that looks like an arithmetic progression. because these are all the same value, then yes, this is an arithmetic progression, and D equals 5 over 4. And that can happen. You can add a fraction. Excuse me. It doesn't have to be a wonderful looking number for it to be one of these sequences for you. All right, the next question. Determine if 4, 5, 7, 10, etc. is an arithmetic progression. Okay, so this guy, if you look here, you've got a difference of 1 between them, 2 between them, 3 between them. And because these are all different, no, this is not an arithmetic progression. And remember, their directions in varsity were if it was no, then you were going to put D and E in varsity. Okay? All right. This is 11.2. We're going to turn the page. We got a few more examples where you're going to do some work here. Paper. All right. So we have those formulas, right? In an arithmetic sequence, A sub 1 equals 4, and D also equals 4. Find A sub n, so you need to find the nth term, and A sub 33. All right, so going back to page 1, where we had those formulas, we're going to use this first blue formula right here, A sub n. They gave us A sub 1, they gave us D, and we're going to utilize n as a variable. So I'm going to write down that equation right there. Actually, let me just do this. I wonder if I can get the whole thing. If not, I'll just rewrite it. But if I can, that would be handy. Nope, I can't. All right. I thought I could shortcut some things, just be kind of slick, Not going to work out. All right, so we're going to start with this. A sub n equals A sub 1 plus n minus 1 times D. All right, well, we know A sub 1, so we're going to substitute that and substitute that. So A sub n equals 4 plus n minus 1 times 4. And now my next step's going to be to distribute. And then these are going to cancel each other. And that's actually my answer. So your nth term needs to have an n, the variable, in the expression. Well, the equation, actually. Okay, so make sure if you're asked to find the nth term that you're not getting rid of that altogether. Okay, and then if we're asked to find A sub 33, now what we're doing is we're using the same formula right here, except we're going to substitute A sub n with A sub 33. So A sub 33 is equal to A sub 1 plus n minus 1 times D. Now, remember, n is the subscript, right? So 33 is equal to n in this problem. And we know A sub 1 equals 4, and D also equals 4, so we know everything. So we're going to plug some stuff in here. Let's go a sub 33 equals 4 plus n is 33 minus 1, and d is 4. So now you've got, just make sure you do your order of operations or plug it into a calculator the right way. This is 32 times 4. So you end up with a sub 33 equals 132. So that means if you were to take this thing out 33 terms, so you have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, blah, 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 to a sub 33, that the value of this term is 132, right? And this one starts at 4, so, and d is 4, right? The difference between them is 4. So this would be 8, 12, 16, 20, and you can just increase by 4 every single term, blah, 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 till you get to a sub 33. So that's what's happening with a lot of these. You only have two formulas, a sub n, finding the nth term. Remember that a sub 1 is always your first term. N is the number of terms. That's important. Sometimes that gets missed. N is the number of terms. You need to know that. D is the common difference. Right? You need to know that. You can find D. This should be, you can calculate D by taking any two terms, a sub 2 minus a sub 1, or technically, right, you can do a sub anything minus any term minus 1 less than it to get your common difference, right? And you guys need to start thinking in terms of generalities like that. You can't always think of such concrete things like this, right? Twos and ones. You need to start thinking in terms of those kind of general things. All right, next. The next one, if you're near the bottom of a page, I would recommend you go to a new page. There's going to be a few arrows and things that you might need to make sure you have some space for this guy. All right, and I need to move my chair. Okay, so here's an example. If a sub 8 equals 17 and a sub 15 equals 31, find a sub 1 and d, then find a sub 38. Okay, so this is kind of a multi-part question. Now, the only thing we know about finding an nth term, a sub 38, is this formula. We have this guy that we used a minute ago. Now, we don't know d. We don't know a sub 1. We don't know anything. So here's how you need to do this. All right, we know that to get from a sub 8 to a sub 15, there's 7 terms between these, right? Okay, so we're going to use that information. So the 8th term, I'm going to write this all out. And this applies specifically to this problem. The 8th term, a sub 8, and the 15th term, a sub 15, are related by 7d. 7 differences. You would add d 7 times to get from 8 to 15. So with that being said, so a sub 15 is equal to a sub 8 plus 7d, right? You'd start at 8, the 8th term. You'd add 7 differences. We would arrive at a sub 15. Okay, so we know that a sub 8 is 17 and a sub 15 equals 31. So now we're going to substitute in. I did not spell that right. Substitute and solve for D. Okay, so I'm going to let a sub 15 be 31. I'm going to let a sub 8 be 17. And we know that there's 7 differences between them. So now I'm going to subtract off 17. Those are going to cancel. 31 minus 17 is 14. I'm going to divide both sides by 7. And 2 equals D. Okay, so that was the first thing that we needed to do. And that's the only way that you can do that. So you need to find first, this is the first important thing here, being able to locate this 7D and then set up this equation. Super important, because if you can't do that, you can't find D. Okay, so now what we're going to do is we are going to start at the lowest term we have. We have a sub 8, and we're going to go backwards. And we're going to get to a sub 1. If we know what the common difference is, we can subtract that off until we get to where we need. So we know that a sub 8 is 17. We know the difference is 2. So I'm going to take off 2, and I get 15. 13, 11, 9, 7, 5, and 3. Now I know a sub 1. And those were the first 2 things that was supposed to happen, right? Going back to the very beginning, find a sub 1 and D. We've done both of those things. We now have D and a sub 1. Okay, now, knowing those, we can use this formula to find a sub 38 because we need D and a sub 1. So now, let's go use that formula to find a sub 38. So let me get a pen. Let me get a color I haven't used here too much. So we're going to find a sub 38 is equal to a sub 1, and I'm just going to rewrite. I like to rewrite these formulas. I can never remember them, and then I like to just sub in what I can. So a sub 38, a sub 1 is 3, plus n is the subscript, so that's 38 minus 1, and d is 2. All right, so that being said, 28 or 38? Oh, well, I have 28 in my notes, but I think I wrote 38 up there, so we'll just do this. All right, so I have a sub 38. I'm going to need a calculator. So this is 37 times 2. Oh, what's 37 times 2? 14, so that's 74. So a sub 38 equals 77. And that would be the last answer that we needed for that question. So that's a giant multi-part question. But if you can just think it through, follow the directions, and get what you need, you should be good to go. All right, the last one. Remember, if you're at the bottom of a page, this is 11.2. All right, last page. If a sub 1 is 3 and d is negative 4, find first a sub 13, then find the sum of the first 13 terms. So this is kind of a two-part deal. So first we're going to find a sub 13, and that's using that formula, a sub 1 plus n minus 1 times d. And we have everything we need to do that. So a sub 13, a sub 1 is 3, n is 13, and d is negative 4. All right, so a sub 13, this is 12 times negative, oops. That's a negative 48 plus 3, so a sub 13 is negative 45. There's that answer. Now, we haven't used the sum formula yet, but taking a look back at the beginning, that was the second one I had you write down. That's the one in yellow. So the sum, n represents the number of terms we're summing. Then we're going to put the n here, so 13 over 2. And then we're taking the first term, and we need to know what that 13th term in this case is. So a sub n. So it's necessary to find that term in order to use this formula. So we'll go back here. I'm going to rewrite this guy. So s sub n, let's make that a 13. So s sub 13 equals, I'll write the generic formula first. A plus 1, a sub 1 plus a sub n. All right, so we have s sub 13, n is 13, a sub 1 is 3, and a sub n we found over here to be a negative 45. All right. And you do generally want the fractions for these unless they're super wacky. So this is a negative 42. What I would do, I mean, most of you are probably going to use a calculator, but I would cancel this guy into here and get a negative 21 and then multiply the 13 and the 21. So s sub 13 is equal to a negative 273. And what that's telling you is if you took the first 13 terms, a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, you get it. Added them all together, you're going to end up with a negative 273. All right, that's the last example I have, I think. Let me check. Yep, for this lecture. There's a bunch of different types of questions in here, but these are the only formulas that you need. However, they're going to require some manipulation. Like some of them, they give you the sum and they tell you to find a sub n or a sub 1 or something like that. So you need to do some manipulation of those types of things. All right. So good luck. Just kind of think outside the box and use your brain. You'll do great. I know you will. Toodaloo.